The need of construction for humans is as old as the history of mankind. Evolving from mud, stone, and wood construction, the ever-durable and promising material concrete made its way in construction during Roman and Greek times and swept off the old techniques quite swiftly. With the world population increasing exponentially and industrialization taking over the world, concrete has become a staple nearly impossible to replace. When we say concrete, we mean an adhesive mixture of cement and water bonded with aggregates presently being manufactured at a rate of 30 billion tons per year, which averages up to around 4 tons of concrete consumed per person. As magnificent as it may seem for the construction industry, numerous fatal flaws of its use have emerged over the last few decades, with climate change and global warming topping the chart. But are these the only hazards of using concrete? Not really. Apart from the enormous carbon footprint and hazardous emissions of contaminated gases, concrete massively devours natural resources, thereby depleting huge quantities of sand, gravel, limestone, and fresh water.
Here Detroit. Concrete, being second to water, is the most widely used substance on the planet. Itself is one of the major consumers of water. According to concrete surveys, the concrete devours 16.6 km of water annually, equivalent to the annual domestic use of 145 million United States residents, all of it only during the process of mixing. Activities such as washing of aggregates, curing not only increase the percentage of water used but also contaminate the water with enough toxicities, barring it from being used again. Speaking of water, there is nothing more essential to life on the earth than water, but the rate of consumption of fresh water is devastating and poses an alarming threat if we continue to do so the same way. The United States nations forecast a world population growth of 1 billion in the next decade, which will amplify the demand by 40% by 2015, and 25% of people will live in countries without enough access to clean water. The extent of these demands, when placed against the constraint of time, resources, funds, and the lack of plans to manage droughts, confirmed it. World is on the brink of water crisis. With freshwater consumption continuing to exceed rapidly, the costs have risen globally, and according to ACI's 2019 report, a single family spends $512 annually on clean drinking water. According to UNICEF, almost 2/3 of the world population experience severe water scarcity for at least 1 month each year, and over 2 billion people live in countries where water supply is inadequate, with some 85 million people lacking access to clean water, giving rise to death toll due to unavailability of water. The climate crisis itself is a water crisis, and it's about time to conserve it before it's too late.
Realize how big the catastrophe is? Let's find a way out. To counter this conundrum, several studies to utilize seawater in concrete have been conducted all over the globe, and it is a fact that many existing structures have been built with seawater in concrete, dating back from Roman civilization to recent Japanese structures. Steady growth in research, both in terms of the properties of concrete itself and from a sustainability point of view, is evident. Concrete, when exposed to seawater, experiences some chemical action arising from the number of dissolved salts present in seawater. Research revealed that seawater in concrete can increase the compressive strength compared to using fresh water. A very interesting phenomenon to be studied experimentally using local materials and cement containing fly ash and slag, which is indirectly participating in reduction of carbon dioxide emissions. Cement is composed of 4 main compounds, namely tetracalcium aluminoferrite, tricalcium aluminate, tricalcium silicate, and dicalcium silicate. When water is added to cement mixture, the hydration products such as toblerone gel, also known as CSH gel, and calcium hydroxide start depositing on the hydrated cement. CSH gel largely contributes in the strength of concrete. The other compound, calcium hydroxide, is able to protect reinforcing steel from corrosion. However, calcium hydroxide also causes leaching. Leaching of calcium ions increases the porosity of cement-based materials, providing an entry for aggressive harmful ions, which causes the steel reinforcement to corrode in later times, resulting in a negative impact. Thus, when calcium hydroxide is lowered, compressive strength is increased.
But what can be done to eliminate calcium hydroxide from concrete? The answer is simple: using seawater. Abundant sodium chloride present in seawater reacts with calcium hydroxide to form calcium chloride. Calcium chloride then reacts with tricalcium aluminate to form Friedel salt, which increases the pH and activates hydration of a cement and providing a denser paste structure with smaller pores. If the chloride ions contained in water react with cement, some of cement hydrating products will bind chloride ions in the concrete either through chemical bonding or through physical adsorption. When the amount of bound chloride has reached its maximum point and there are no more elements or compounds in cement that can bind chloride, the remaining ions penetrate into galvanized layer of steel. Therefore, can be concluded that the presence of NaCl in the seawater can bind calcium hydroxide compounds, causing the compressive strength of concrete to increase substantially. Continuous reaction between sodium chloride and calcium hydroxide produces Friedel salt, which directly fills the pores in the concrete, improving the strength and durability. From the microstructure review, the taubermovite increases up to 7.31%, tridyl salt up to 7.71%, and calcium hydroxide decreases about 15.82%, which can cause a difference in compressive strength of about 1.93% between a seawater concrete and a freshwater concrete.
Rooting for concrete sustainability and resource preservation, it has to be asked how much water can we save by substituting seawater in concrete. A US standard block made with seawater can save up to 1 liter of water per block, and with an average amount of 3,000 blocks used in construction per house, we can save up to 3,000 liters of fresh water, which are enough to fulfill the daily drinking requirement of 810 people. With the humongous consumption of concrete, using seawater in the mix can save almost a tenth of the world's industrial water, and amidst the crisis looming over this, reverse can add international global goals to mitigate water crisis, such as Sustainable Development Goal number 6, established by the United Nations about clean water and sanitation for all. With 11 global indicators to track progress of affordable, clean, and sufficient availability of fresh water around the globe. Water being the evidence of all living organisms makes it hard to ever imagine our lives without it. Each day passing by with depletion of water, we are threatened by the impacts of water on our food, our energy, our health, and ultimately our lives. Concrete not only giving up the consumption of fresh water, but pacing towards the enhancement in sustainable properties by displacement of seawater, only invest in the prosperity of the upcoming generation. It's time we take responsibility. Seawater concrete, the key to sustainable future ahead.